Right, let's take a look at this one. So here we've got to complete the following tables. We're given an input, which is the important thing. Okay, remember the output is just the answer. It depends on the input. So when the input is 1, okay, right here, okay, what's the output? If it's 10 more than that, well, if it's 10 more than that, okay, it must be 11. Okay, 10 more than 1 is 11. If we've got 3, what's 10 more than that? We'll add 10 to 3, I get 13. Again, with a 5, 10 more than that is 15. So I'm just adding 10 to all of these inputs. And I think to myself, okay, if I'm doing that then surely, watch this, y equals, and as the output equals x plus 10. I'm adding 10 to the input. Alright, if we call the input x, kind of as usual, and the output y, okay, then can you see it's 10 more than the input? It's x plus 10. Here's my input, which is x. If I add 10 to it, I'll get the output. I'll get the answer y. So that's what the equation is for that one. If I look at this one over here, okay, now the output is 3 times the input plus 2. So if I just say to myself, 3 times the input, right, if the input is negative 5, what's 3 times that? Isn't that negative 15? Okay, if I add a 2, okay, back up the number line, that's negative 13. Okay, how about this? I'll just erase that. How about the negative 4? Okay, negative 4. So again, what's this one here? 3 times negative 4. 3 times negative 4 is negative 12. If I add a 2, okay, back up the number line, that's negative 10. Okay, negative 12 plus 2. Okay, let's just do a couple more. Let's actually move down a little bit. Down here. Okay, you know what the easy one is it's always when input is 0. Alright, that's nice is that one, okay? Because think about this. 3 times the input. What's 3 times nothing? Nothing. When you add a 2 plus a 2, you'll just get 2. Okay? How about this one here? Alright? A bit easier numbers when they're positive, aren't they? 3 times the input. 3 times 1 is 3. If you add a 2, you'll get 5. Okay, so I'll just do those 4. I'm not going to do every single one of them, okay, because what I have here is I'm going to write this. So based on this over here, this equation, okay, I'm going to think to myself, okay, if this is y equals, okay, we'll write them like this, y equals, okay, what's happening to the input to get to that y, okay, what's happening, how do I get the output? It looks like it's 3 times the input. If the input again is x, again I'm calling the output y, so what does y equal, right? So, 3 times the input, well if the input is x, I'm saying, well that's 3 times x. If I then say plus 2, that means I'm adding 2. Now I can actually use this equation to actually create these output answers here on this right hand column. In other words, look at this, let's go for this 2 here, okay? If I use 2, and I write it right here, when x is 2, right there, what's 3 times 2? It's 6. And then add a 2, you get 8. So I put 8 for that. Okay. Now that's the verbal rule. I'm thinking to myself, what's 3 times the input? 3 times 2 plus 2. Yes, okay. Now I'm just showing you how to create the equation as well. Okay. Now if we had to graph these, right, the problem with some of this is, again, using appropriate scales. Well, with number 3, you know, I can do 1 to 14 on the bottom. So the x-axis for this one is not too bad. If I draw a line on the bottom here, I'll just make it a little bit thicker. Okay. Now then, if I draw a line up here, because there's no negatives here, there's no negatives, so I'm just going to do that. I'll draw a line up there. Do that one a bit wider. So I've got to go back and think to myself, right. So 1 to 4, that's not bad. I'll probably mark 1, oops, get some straight lines going, again, 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, so I'll mark it there, okay, so I'll do that for now. Problem is, with the y-axis, okay, if I had to go to, I'll just go as far as, let's say, 12. Again, when I add a 10, I'll get 22. So I'll just go as far as 12. Now, from 11 to 22, so I don't need to start at 0 then, really, if I don't want to. It's actually starting at 11, okay? So if I did this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, My first number's not till there. It's not. I'm starting there, so it's like I'm wasting all this here. So supposing I said I'm going to start at 10. Then this is 11. This is 12. You don't have to start at 0 if you want to. 13, 14, this is 15. Okay, 15, 16, 17, 18, 19, 20. Okay, 20 here. So that would be 21. Okay. So that's what I would do. I think I'll start at 10 instead, because I don't need anything below 10, below 11 really. So when x is 1, y is 11. When x is 1, here we go, point right there, y is 11. Okay. When x is 3, y is 13. So when x is 3, y is 13. Okay, right there. When x is 5, y is 15. Y is 15. There we go. Now I'm going to draw a straight line here. I'm just going to show you something right now. So I'm going to draw the straight line. Okay. But I'm actually going to keep on going. Suppose I draw that and it kept on going forever. Okay, so suppose I keep doing this. It's not magic, isn't this? Alright, so here we go. There is my straight line. Okay? Going through those 3 points. But have a look at this. Let's go back to the table. Let's do this here. Let's do this one here. That 12. Remember, when x is 12, y is 22. When x is 12, y is 22. Let's have a look. Here's 11. Here's 12. I'll go oh yes, it is 22. Look at that on there. Yeah. So it matches it. It's because this is a straight line graph. Okay. All the points here, all these ordered pairs have to lie on that straight line. Let's do another one. Let's do 7. What's that? Add 10 is 17. When x is 7, y is 17. Is it? 7's right there. It hits the point here. Is that 17? It is. There's 15, 16. Yep, it's 17. Okay? So it's not magic. Okay? It's just these points have to lie on the straight line. And if I do the rest for this one, okay, if I plot this one, I'm not going to do that one as well. The thing of that one is it starts at -5. So there's a lot of negative numbers here. So it maybe I kind of do one of those axes that looks like this. So get some lines going. I might do it right down the middle here. So there is a line. I'll just make it a little bit bigger so you can see it. Okay. I'll put one right across here. So it's got all 4 quadrants. Remember that? I just used quadrant 1 for that first one. So there we go, 4 quadrants. And then I would do things like this. Okay, so when x is -5, y equals -13. So I'd still use -1. Oh, let's get the pen going again. -1, -2, -3, -4. There's -5, okay? But if I had to get down to -13, I can't do every one, so maybe 2, 4, 6, 8, 10, 12, maybe I'll do 2, okay, so -2, -4, -6, -8, -10, put a -10 there. So can you see the slowest I'm going to go down to, down here, -12 is -14, and that'll work, okay. So I've got to do each little square is 2, so be careful about this, okay. So when x is -5 and y is -13, so remember, -5 on the x-axis, -13 on the y-axis, that's going to be between -12, that's going to be about there, okay, about there. And let's do another one. -4 will give me -10, so -4 will give me -10. And let's just jump to some of the positive ones. So when x is 0, y is 2. Remember, x is 0 is right in the middle here. So when y is 2, remember I'm going every 2, that's 2 there, isn't it? Okay, that's 2 there. So that's the point right there for x is 0, so nothing on the x-axis, just right in the middle, but y is 2. And remember, 1 square is worth 2 for this. And finally, when x is 1, y is 5. So when x is 1, y is 2, 4, somewhere in between 4 and 5. Now watch this again, okay? I can see a straight line. If I put this there and do this, it's going to be another straight line, okay? It's going to be another straight line. I'll leave that like it is. So hopefully, all points that lie in between those will also be on the straight line. If I do, let's have a look at this one here. We haven't done this one here. When x is -2, what's 3 times that, 3 times negative 2 is negative 6. Alright, when I add a 2, I'll get negative 4. So there's another point. Negative 2 on the x, y is negative 4. Is that right? Negative 2 on the x is there. Okay, there's negative 2, remember. Does it go down to negative 4 there? Yes, it does. Look at that, remember? That's negative 4 there, because we're doing every 2 on the y-axis. So again, all those points will lie on the straight line. Okay, there you go.